Good day, this is Sir Renato Roldan, and in today's video I am going to share to you the intercepts and zeros of rational functions. Okay, so before the examples, let us first define the x-intercepts, the y-intercepts, and the zeros of rational. So the y-intercept of the graph of a rational function r of x is if it exists, of course, at r of 0, provided that r of x is defined at x equals 0. So in finding the y-intercept, we are going to set the value as of x as 0. While the x-intercept of the graph of a rational function r of x, if it exists, of course, at the zeros of the numerator that are not zeros of the denominators. To find the x-intercept, equate the function to 0. And the zeros of a function are the values of x which make the function 0. Okay, so let us find the x-intercept and the y-intercept for f of x equals x minus 3 over x plus 1. So as we have said on the definition, to get the x-intercept, we are going to set the value of y as 0. Since f of x is equal to y, therefore, we're going to change y, or we're going to let the value of y equal to 0. So 0 is equal to x minus 3 over x plus 1. Okay. So to get the value of x, we have to cross multiply, or we have to multiply x plus 1 times 0. So if we multiply x plus 1 times 0, the product is also 0, equals x minus 3. Okay, for it easy to get the value of x, interchange 0 and x minus 3. So you have x minus 3 is equal to 0. So pwede natin i-interchange para mas madali ang pagkuha ng value ng 0. So using the addition property of equality, or by transposition, x now become positive 3. So we are going to transpose negative 3 to the right side of the equation. So as you transpose, you're going to change the sign. So since this is negative, it will make positive. And therefore, the value of x is equal to 3. So what would be the x-intercept? The x-intercept is an ordered pair with x, which is 3, comma, and y, which is 0. So the x-intercept of the function is at 3, 0. Okay, so finding the y-intercept. In finding the y-intercept, we're going to set or let the value of x equal to 0. And therefore, y is equal to, we're going to let the value of y to, or x as 0. So we replace 0 to x. So it becomes 0 minus 3 over 0 plus 1. So remember that y is the same as f of x. So that y is equal to 0 minus 3 over 0 plus 1. And therefore, y is equal to 0 minus 3 is negative 3 over 0 plus 1 is equal to 1. Dividing negative 3 by 1, the quotient is negative 3. So therefore, this is the value of y. So y is equal to negative 3. So what would be the y-intercept? What is our y-intercept now? So the y-intercept is at 0, which is the value of x, comma, negative 3, which is the value of y. Okay, so the y-intercept is 0, negative 3, and the x-intercept is 3, 0. Okay, so another example, find the x and y-intercept for f of x equals x squared minus 3x plus 2 over x squared minus 4. So as we can see, both the numerator and the denominator are factorable. So first, we're going to change f of x to y, and then let us factor the numerator. So we're going to factor the numerator. We're going to find the factors of x squared and the factors of positive 2, whose sum is negative 3. So what are the factors of x squared? You have x. The factors are both binomial. You have another x, so x times x is x squared. Factors of 2, you have 1 and you have 2. Okay, so we are looking for the factors of 2 whose sum is negative 3. So what must be the sign? It should be negative 1 and negative 2, because negative 1 plus negative 2 is equal to negative 3. Then factor x squared minus 4 into x. For the factors of x squared, you have x and the other x. Since it is perfect square, the factors are of 4 are negative 2 and positive 2. So there are similar factors for both the numerator and the denominator. So if that happens, we can cancel them. So we have x minus 2 on the numerator to be cancelled out with the x minus 2 in the denominator. And therefore, the remaining factors are, you have x minus 1 for the numerator and x plus 2 for the denominator. Okay. Finding the x-intercept, you're going to let y equal 0. So then, multiply 0 by x plus 2, so it becomes 0, and therefore it is equal to x minus 1. So you can interchange x minus 1 equals 0, and therefore x transpose negative 1 to the right side, so it becomes positive 1, and therefore the value of x is positive 1. Sorry. So what is the x-intercept? The x-intercept now is at 1, 0. Okay, let us solve for the y-intercept. So the y-intercept, in finding the y-intercept, we're going to let the value of x equal to 0. So let us change f of x to y. So y is equal to, okay, so we're going to replace x by 0. So x squared becomes 0 square minus 3 times 0 plus 2 over 0 square minus 4. Okay, so 0 square is equal to 0. 3 times 0 is also equal to 0 plus 2 over 0 square is also 0 minus 4. So it is equal to 0 minus 0 is 0 plus 2. It is 2 over 0 minus 4 is negative 4. And therefore, it is equal to negative, we're going to reduce the lowest term. 2 over negative 4 is equal to negative 1/2. Okay, sorry. So this is negative 1/2. So the value of y is negative 1/2. Okay, so what is the y-intercept now? So the y-intercept is at 0 for x, comma, negative 1/2. Okay, so the y-intercept is 0, negative 1/2, and the x-intercept is at 1, 0. Okay, so the next one is finding the zeros of the rational function. Let's say find the zeros for f of x is equal to x minus 2 over x plus 6. So how can we find the zeros of the given function? So simply equate the numerator to 0. But first you're going to look if there are factorables for both the numerator and denominator. So, but since in the given function, both the numerator and denominator are prime, so therefore we just jump to equating the numerator to 0. So our numerator is x minus 2, so just equate x minus 2 to 0. So you have x minus 2 equals 0. So remember na gagawin nyo lang siya kapag hindi factorable yung numerator and denominator, or kapag prime na yung numerator at denominator. You just simply equate the numerator to 0 to get the zeros. And therefore, transpose negative to the right side of the equation. So you have negative 2 becomes positive 2. And therefore, the zeros of the function is equal to positive 2. So ito na yung zeros of rational function. So bakit siya yung zeros? Because as defined, the zeros of the rational function is the value of x that will make the zero or that will make the function equal to 0. So if we're going to substitute the value of x to the function. So let us check. We're going to substitute the value of x, which is 2, to the function. So this will become 2 minus 2 over 2 plus 6. Yan. So 2 minus 2 is equal to 0 over 8. So 0 divided by 8 is equal to 0. In that, the function becomes 0 at x is equal to 2. So the zeros is equal to positive 2. Okay, the last one is find the zeros for f of x equals x squared plus x minus 2 over x squared minus 4. So there are factorables for both the numerators and denominators, so we cannot jump into equating the numerator to 0 since the numerator is still factorable and also the denominator is still factorable. So we are going to factor first both the numerator and denominator. So let us factor y is equal to factors of the numerator. You have to factor 2 whose sum of the factors is positive 1. So let us split x squared into x. Yan. Factors of x squared are x and x. So the factors of 2, you have 1. Sorry, you have 1 and you have 2. Okay. So what must be the sign of 1 and 2? So 2 must be positive and 1 must be negative. Okay, so these are the factors. Then factoring x squared minus 4, you have to split the factors of x squared. Perfect square yung 4, so you have x2, x2. So since perfect square yon, so the factor must be 1 positive or negative and 1 positive. Okay, let's look at the factors. There are the same factors for both the numerator and denominator, so we can cancel those factors. We have x plus 2 to be cancelled out with x plus 2 in the denominator. So therefore, the remaining factors, you have x minus 1 over x minus 2. So as we have said earlier, since prime na yung numerator and denominator, pwede na natin i-equate yung numerator to 0, which is x minus 1. So we can now equate x minus 1 or the numerator to 0. So you have x minus 1 is equal to 0. And therefore, x is equal to 1. So it means that the function will become 0 if the value of x is equal to 1. Let us see. So 1 square plus 1 minus 2 over 1 square minus 4. So 1 square is equal to, let us find this here, place this here. 1 square is equal to 1 plus 1 minus 2 over 1 minus 4. So 1 plus 1 minus 2 is equal to 0, and 1 minus 4 is equal to negative 3. 0 divided by negative 3 is equal to 0. Okay, so therefore, the function becomes 0 at x is equal to 1. Okay, so thank you for watching the video. I hope you learned something from it.